angles that a transversal creates. Remember, at any time during this video, you may pause it to take notes or think about it. What is a transversal? A transversal is a line that passes through two lines at distinct points. Here are 3 examples of transversals. The orange lines are the lines that the transversal is passing through, while the purple lines are the actual transversal. As you see here, it says it can only pass through distinct points. And as you see here, the transversal is passing through 2 distinct points, clearly marked in red. Now we will be going over vocabulary that is fundamental to learning the angles of a transversal line. What is a supplementary angle? A supplementary angle is 2 angles whose sum is 180 degrees. As you see here in this diagram, both x and y have a sum of 180 degrees. A line is equal to 180 degrees. Therefore, if 2 angles equal a line, they are 180 degrees. But that is not the only way they can be supplementary. If x was 20 and y was 160, then they would still be supplementary angles because their 2 measures have a sum of 180 degrees. Now we'll be going over the 7 types of angles that a transversal creates. The first 3 are alternate interior angles, same-side exterior angles, and a linear pair. The other 4 angles that a transversal creates are alternate exterior angles, same-side exterior angles, vertical angles, and corresponding angles. Don't forget to remember, at any time if you are having trouble, you can stop and pause the video, rewind it, and watch it again. Here is one of the angles that a transversal creates when intersecting 2 lines at distinct points. It is called an alternate interior angle. The properties of these are, they both are interior angles, they have different vertices, they are on opposite sides of the transversal, and they form a Z shape. As you can see here, we are comparing angles 4 and angle 6. We know these are alternate interior angles because they are both interior angles. If you look at lines A and B, and you look at the space in between them, both 4 and 6 are inside. Therefore, they are both interior angles. They have different vertices. This is a vertice for angle 4, while this is a vertice for angle 6. So they have different vertices. They are on opposite sides of the transversal. This is a transversal, while 4 is on the left side, 6 is on the right side. So they are on opposite sides of the transversal. Lastly, they form a Z shape. When you trace the lines and angles of 4 and 6, they come with a Z shape, which is only for alternate interior angles. That is a way you can remember if you see one. Next in our list is same-side interior angles. The properties of these are, they are both interior angles, they have different vertices, and they are on the same side of the transversal, and they form a C or U shape. As you can see in this example, we are comparing angle 3 to angle 6. They are both interior angles because they are between the space between the lines A and B. They have different vertices. Angle 3's vertices are here, while angle 6 vertices is here. They are on the same side of the transversal. There are none on the left, but they're both on the right. And finally, the best way to remember if you see one is they form a C or U shape. As you can see in this diagram, when you outline the lines and angles, angles 3 and 6 create a C shape. Vertical angles. These are my favorite type of angles because They can easily be identified anywhere. The properties of these are, they are angles created by two intersecting lines, they are congruent to each other, and they form an X. Here, angles T and angles A are intersecting, and we're looking at angles 1 and 3. They are both congruent to each other, and they form an X when you trace the angles and lines. Therefore, they are vertical angles. Next in our list is alternate exterior angles. Both angles are exterior, they have different vertices, and are on opposite sides of the transversal. They're both exterior because when you look at the space between A and B, both angles 1 and 7 are not in between. So they are both exterior. They have different vertices. Angles 1's vertices here, while angle 7's vertices here. They are on opposite sides of the transversal. If you do this, on the left is angle 1, while on the right is angle 7. Therefore, they are on opposite sides of the transversal. When you highlight the angles and lines that they have, it creates like a double L shape. That way, if you ever see them, you can recognize them. Next is same side exterior angles. They are both exterior angles, they have different vertices, and are on the same side of the transversal. You can see they are both exterior angles because both 1 and 8 are not in between the A and B line. They have different vertices. Angle 1's vertices here, while angles 8 vertices here. They are both on the same side of the transversal. If you look from on the right side of the transversal, there is nothing there. But if you look on the left side, both angles 1 and 8 are there. Therefore, they are on the same side of the transversal. Since all these properties are true, they must be same side exterior angles. Another set of angles are corresponding angles. Their properties are one interior angle and one exterior angle. They are on the same side of the transversal, and they form an F shape. Here we are using angles 2 and angle 6. They are one interior angle and one exterior angle. When you look at the space between A and B, only angle 6 is inside. Well, if you look from A and up, you see that angle 2 is exterior. So therefore, there is one interior and one exterior angle. They are on the same side of the transversal. When you look on the left of the transversal, there is nothing there. But when you look on the right of the transversal, you can see both angles 2 and 6. They form an F shape. As you can see here, when you trace the lines and angles of 2 and 6, you can see they form an upside down F shape, which tells you they are corresponding angles. Linear pair. The properties of a linear pair are two adjacent angles whose non-common sides form a straight line. These angles are supplementary and they form a T-shape. The definition of adjacent is that they are touching together. As you can see here, angles 8 and 7 are touching each other at one ray. And their non-common sides form a straight line. Their non-common side are these, while their common side is these. These angles are supplementary. Since a line is 180 degrees, if they both form a line, they are supplementary. And lastly, the easiest way to remember these is they form a T-shape. When you outline the angles and lines, they create a T. Now, for some practice problems. You are going to look at the angles highlighted in pink as one pair and the angles highlighted in yellow as the next pair. And you are going to identify whether the angles in pink are vertical angles or the angles in yellow are vertical angles, or whether the pink is same side interior angles or angles 3 and 5 are interior angles. You can stop the video and pause it and figure out the answer by yourself and watch the answer as it comes up afterwards. Okay, now for the answers. As we look at angles 1 and 4, we know that they are vertical angles because of the properties of vertical angles. Vertical angles are angles created by two intersecting lines, like this line and this line. They are congruent to each other, and they form an X when you outline them. As you can see, they formed an X, so there are the vertical angles. Now, by the process of elimination, you can tell that the angles highlighted in yellow are same-side interior angles, but as in geometry, you always have to convey proofs for saying they are same-side interior angles. Here, we have the properties of same-side interior angles. We know yellow is same-side interior angles because they are both interior angles. They have different vertices, here and here. They're on the same side of transversal. They're both on the left, and they form a C or U shape. As shown here. Therefore, the yellow angles, are same-side interior angles, while the pink ones are vertical angles. Thank you for watching my videos, and I hope you enjoy it.